I'm going to explain about the capital PDF probability distribution function denoted with capital F of X. We can call it as F of X. PDF is defined as it is an cumulative addition of probabilities, or else the graphical representation for the cumulative addition of the probability is called as capital PDF. I will tell you. So before that, we know that the random experiment means we don't know the outcome before completing the experiment is called as an random experiment. What is an outcome means we know that it is the final outcome for the given random experiment. Final outcome. So coming to the PDF, it is an cumulative addition of the given probabilities. So I am assuming here we can see this. I will give the one example. X is a random variable having the probabilities. So 1, 2, 3, 4 x values and p of x probability corresponding probabilities are 0.3, 0.2, 0.3, 0.2. So these are the corresponding probabilities. Or else this X is a company and they are designing something, some boards with the probabilities. The first day they are designing with the probability 0.3. Second day they are designed with the probability 0.2. Third day they are designed with the probability 0.3 and 4.2. So then we can see this. Then what is an distribution for this? Denoted with capital F of X. So is equal cumulative addition of the probability 0.3 plus there is no cumulative previous one. So that's why it is 0.3 only. Next value 0.2 plus previous probability is 0.3. So that is equal 0.5 is the distribution. And here the distribution is 0.3 plus 0.2 plus 0.3. So is equal 0.8. And similarly it is 0.2 plus 0.3 plus 0.2 plus 0.3. Total it is 1. So that's why the PDF is denoted as cumulative addition of the previous cumulative addition of the probabilities is also called as distribution function denoted with P of x less than or equal to x. That is the meaning. For example, f of 3, for example, x value means P of x less than or equal to P of x less than or equal to x is equal x less than or equal to 3. X value is 3. So x value is 3 means here you can see this less than 3 values are x equal to 1 here plus x equal to 2 plus x equal to 3. So that is the meaning for x less than or equal to 3. That's why here you can see this. So this is an cumulative addition. Cumulative addition for the given probabilities is called as probability distribution function. Sometimes it is also defined as graphical representation for the cumulative addition. How it is representing the graphical representation? So here you can see this at 1 it is having at 1 it is x value, this is x value, and this is an distribution capital F of x. So here at 1 it is having 0.3 probability 0.3. Here I am assuming at 2 it is having 0.5. I am assuming 0.5 is here. I am assuming 0.5. And at 3 it is having 0.8. 0.83. I am assuming here 0.8. And at 4 it is having 1. So it is 4 at 1. So draw the like unit step. So PDF is denoted with like unit step function. If we take small PDF, it is denoted with impulse. So I will tell you anyhow. So this is an graphical representation for the probability distribution function. So coming to the here one more example. Here 1, 2, a random variable x is having 3. Here 4 values are there. 4 real numbers. For that, the corresponding probabilities are 0.2, 0.3, 0.4 and 0.1. Then what is an capital PDF? So present probability 0.2 plus next probability is 0.3 plus zero point 0.2, 0.5. Next is 0.4 plus 0.3 plus zero point 0.2, 0.9. 0.1 plus zero point 0.4 plus zero point 0.3 plus zero point 0.2, 1. So this is the cumulative addition. So like this, we can find the capital PDF. Coming to the equation, mathematical representation, as I said, fx of x equal to p of x less than or equal to x. So I'll tell you one example. You may ask the questions in the university exams like this. Find fx of x equal to 3 and or else find the p of x greater than or equal to 3. I will give the one example. So x is a random variable having the values -2, distribution -1, 0, 1, 2 and 3 is there. I am assuming. So corresponding probabilities are 0.2, 0.1, 0.2, 0.2, 0.1, 0.2. I think it is total should be always 1.4, 0.4. Yes. So P of x, this is the corresponding probabilities. So then we need to find our required the given functions, given distribution function as well as the probabilities. So here, so P of x and 0.2, point -1, 0, 1, 2, 3. So now P of x greater than or equal to 1 we can calculate easily. The second bit we can calculate easily. What is the second bit? P of x greater than or equal to greater than 1. So greater than 1 values are 2 and 3 only. So this is equal P of x equal to 2, P of x equal to 2 greater than 1 values plus P of x equal to 3, P of x equal to 3. So we can calculate P of x equal to 2 value is 0.1 plus P of x equal to 3 value is 0.2 is equal zero point 0.3. So this is the way to calculate P of x greater than 1. For example, if it is x less than 1 means x less than 1 are 0, -1, -2. So means 0.2 plus 0.1 plus 0.2 is equal to 0.5. And similarly, the first bit we can say this, we need to find f of x equal to 3 is asking. X equal to 3 is asking. So that is equal, formula is P of x less than or equal to 3. So according to PDF, capital PDF, f of x equal to P of x less than or equal to 3. So now P of x less than 3 values are x less than 3. Less than or equal to 3 means total values. You can see this. Less than or equal means 3 value, equal value 3, 2, 1, 0, -2, -1. All are less than 3 values only. So that's why we can less than 3 values are f of P of probability of x equal to -2 plus probability of x equal to -1 plus probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3, x equal to 3. So therefore the total values are 0.2 plus 0.1 plus 0.2 plus 0.2 plus 0.1 plus 0.2 is equal to 1. So like this we can calculate the probabilities. Most of the time he may ask the questions like this only. Sometimes he may ask f of P of x less than or equal to 0. P of x less than or equal to 0. So less than or equal to 0, 3 value means 0 value means 0 value, -1, -2. So like this we need to calculate the distribution function. And coming to the properties, always the maximum distribution is equal to 1. the minimum distribution is 0, and always it is lies between 0 to 1. I'll tell you how it is. So, and always the present distribution is greater than the next distribution, because you can see this, the distribution of, here you can see this, always present distribution is 0.3 here, the next distribution is 0.5 here, 0.5 here. So that's why always, because it is an cumulative addition, that's the reason the present is greater than the previous one, previous distribution, always. And one more thing, you can see this, always the maximum distribution will get it like axioms of probability. So maximum is 1, always. Maximum probability is 1, maximum distribution is 1, maximum density function is also equal to 1. So that is the properties. These properties are compulsory. Fx of infinite plus infinite equal to 1. Always the maximum distribution equal to 1, and the minimum distribution is equal to 0. Like probability 0 or else greater than or equal to 0. And always the third property we need to remember, that always it is lies between 0 less than or equal to 1. Always it is lies between 0 to 1. So these property, fourth one is always the present distribution. For example, f of x1 is less than or equal to f of x2, because there are two are, this is an cumulative addition, so that is the reason always uh, it is the present distribution is greater than the previous one. Here if we take this one third position, 0.8 is greater than the previous one. So that's the reason f of x1 less than or equal to f of x2. So these are the properties. Always the minimum is minimum probability is 0 or greater than or equal to 0. Minimum distribution is also 0 or greater than or equal to 0. Maximum distribution is 1, and always it is lies between 0 to 1. Thank you.